Welcome to your first video done by me. Before this video, you should have watched why we do the same thing to both sides. That's a video from Khan Academy. And now here's a video I'm going to do for section 2-4 out of your Holt textbooks. But this is for 1-1 Checkerboard Borders from your MVP books that we're using in class. So here's the first video title that you watched, and you should have created notes. And now we're doing the second one. How do you solve an equation with variables on both sides? I'm going to complete 3 examples for you on how you solve an equation with variables on both sides. After you've watched this video, then your next video is going to be what are the ways to remember slope, and that title would go here along with your notes. I want to remind you that if I'm going too fast, you need to pause, write down the information from the slide, and then resume when you're ready to pay attention. If you do not understand the concept at the end of the video, you are to re-watch the video, and you should have already done your notes, so that way you just focus on the video entirely. The examples I'm going to show you will help you with the Ready, Set, Go assignment we will do in class on Tuesday. How do you solve an equation with variables on both sides? We'll answer this question by the end of the video, and we'll talk about how to answer this question in your summary tomorrow in class. You must remember, to solve an equation with variables on both sides, we must use inverse operations to collect variable terms on one side of the equation. So there's a few components in here that I want to talk about with you so that we understand all this vocabulary here. First of all, an equation is going to be a term with an equal sign. So you may have something like 5x equals 3x plus 6. This is an equation just because of that equal sign there. Remember, variables are the letters to represent a numerical value, but we don't know what it is until we solve the equation. And let's discuss inverse operations quickly. The inverse of addition is subtraction. The inverse of subtraction is addition. Inverse of division is multiplication, and the inverse of multiplication is division. So if you see that something's being added on the equation, then you are going to need to subtract, and that's the inverse operation in order to solve the equation. So you'll see me use inverse operations to isolate the variable. Here's our first example. We're going to solve 7n minus 2 equals 5n plus 6. It's an equation. We have variables on both sides, and so the first step is to collect all variables to one side. Now over here on the right hand side, I have the steps, and I'm just going to go ahead and write down the information for you here on how to solve it, and then make sure you write down the steps so you have that process in your notes. First, we're going to subtract 5n to both sides. Since 5n is actually positive, the inverse of that is subtraction, so we're going to minus 5n to both sides. This cancels out, or excuse me, that does not cancel out. How silly of me. Let me see if I go back. Nope. Okay, let's try to erase. There we go. Okay, let's try this again. We're going to subtract 5n. Notice I just made a mistake, and I talked to you guys about making mistakes, but we learned from that. 7n minus 5n is 2n. If you have 7 n's, and then you subtract 5 n's from that, you'll have 2 n's left. You can think of it like food too. 7 Oreos, you eat 5, you have 2 Oreos left. So minus 2 equals, now if I have 5 Oreos and then I eat 5 Oreos, then I have no Oreos left, or no n's left if I subtract 5n from 5n. This equals 6. Now I'm just trying to get this variable alone, so I'm going to box it. And I want to add 2 to both sides, because remember, I want to get the n alone, and the next thing to get rid of is the addition, or excuse me, the subtraction of 2. And now I have 2n equals 8. Divide both sides by 2, and n will equal 4. In order for us to check our answer, we would plug 4 back in for n here, and check to make sure. So let's do that quickly. 7 times 4 is 28. Minus 2 equals 5 times 4, which is 20, plus 6. 28 minus 2 is 26. 20 plus 6 is 26, and this checks out. I encourage you to do the same thing for the next examples. Here's our second example, and I remind you to check your answer. We're going to go ahead and we want to collect the variables all to the same side. But we always want to keep it positive. So I'm actually going to subtract 3b to both sides. There's two ways to do this. I could, oops, that's 36. I could subtract 4b to both sides, but then I'll get a negative variable, and that gets a little sticky. So I don't want a negative variable right now. I want it positive, so I'm going to minus 3b to both sides. But I'm going to do a favor for you. I'm also going to do this another way, okay? So this way I'm doing will go with these steps here in red. So 4b minus b is b plus 2 equals, well, 3b minus 3b is 0. So I'll put a 0 there. It's like a placeholder. I'll subtract 2 to both sides. And 0 minus 2 is negative 2. So b equals negative 2. Okay, let's solve it. We're going to do this a different way, but we're going to get the same answer. So like I said, if I subtract 4b to both sides, I'll get a negative variable, and it gets a little sticky, but it's okay. We'll work with it. So 4b minus 4b is 0. I have 2 equals. Now 3b minus 4b is negative b. We'll talk about looking at a number line for these problems. Divide both sides by negative 1, because we can't have a negative variable as our final answer. And then 2 divided by negative 1 is negative 2. And this equals to negative divided by negative is positive. Notice we got the same answer. It's just flipped. Okay, for our last example, we have a really big one, and it's kind of complicated because we have to simplify each side first. Then we can get all variables to one side. So on the left-hand side of the equation, I need to simplify negative 6a and add that to 4a. So I'm going to have 4, and then negative 6a plus 4a is negative 2a. I only want one variable on one side. And when I talk about sides, I'm talking about what down the equal sign. This is the left-hand side, and this is the right-hand side. And then now for the right-hand side, I need to distribute the negative 5. Anytime I see parentheses and a number or variable on the outside, I must distribute. So the negative 1, this is equal. Negative 1 will stay there, but negative 5 times 7 is negative 35. And negative 5 times negative 2 is positive 10a. And then I have to simplify these two numbers. I can combine them for one number. So I get 4 minus 2a equals negative 36 plus 10a. I'm going to add 2a to both sides to get variables to both sides, or to one side. And I chose the 2a because I don't want a negative variable. So I get 4 equals negative 36 plus 12a. I'm going to add 36 to both sides. And now I get 40, because 4 plus 36 is 40, equals 12a. And divide both sides by 12. And now I have a equals 40 over 12. But I can obviously simplify this fraction. So I'm going to divide the top number by 2 and the bottom number by 2 just to get it smaller numbers. And I get 20 all over 6. I can still go further, so I'll divide the top and bottom again by 2. And I get 10 over 3. And I can go no further. There's no number that's the same number that goes in the top and bottom, or the numerator and denominator. And this is my final answer. This video is a little bit lengthy just because I went through 3 examples, but you'll need the help and the practice for the work we're going to do in class. Please make sure that you copy down all notes. Don't forget about your summary. And don't forget that you have 2 more videos right after this one.